All right, so 6.4 is percents of increase and decrease. Some key vocabulary words that we learned in this chapter or this section were percent of change, percent of increase, percent of decrease, and percent error. So there was a formula that we used that found the percent of change. So to get the percent of change, to get the percent change of the percent error is basically like we did in 6.1, which is just if we find the fraction of the total, that's the change, you can find a percent from a fraction. So to get the percent of change, all we do is say, how much did something change? And then we just put it over the total, which was the original amount. We just compared the change to the original. Sorry, I don't know why I wrote it up there. So the percent of change is you take the change and you divide it by the original. Let me redo that. You just get how much did something change, and you compare it to the original amount, and then that is a decimal. You could then turn that into a percent. Similar thing for percent of error. So if you were off by something, a measurement or a guess, we're comparing the amount we were off. We're going to call that the error, and compare that to what was expected or what happened, like what was it supposed to be. Compare it to what we expected it to happen. So, so for the first ones, it's just a percent increase or decrease. So we're just dealing with the percent change part here. So, so it was 6 yards. This is the original, and now this is the new. So we need to find the change. So to get the percent of change, we need how much did it change and compare it to the original amount. So it changed. It went from 6 to 63. So 36 minus 6 is 30. It increased by 30. So we had an increase, a some percent increase. That's step one. Find the change, and was it an increase or a decrease? So the 30 change, so 30 compared to the original amount is 6. So 30, so it over doubled, it over tripled. It's like 6 times the amount. So it grew by a factor of 5. So 30 divided by 6 is 5. And then don't forget that we want that as a percent. So if we want that as a percent, we need to take the decimal point and move it twice. So 1, 2. So we get 500%. This was a 500% increase, okay? All right, so that was the percent change. That's how to use it, using the formula. You just get the change and compare it to the original. Now, if that's not making sense, here's a visual for it, okay? Our friends, the double number lines, all right? 0% of anything is 0, okay? These are yards here, yards. And the original amount, the 6, this was the 100%, that was the full amount. It grew to 36 or whatever happened. It was 6, it's now 36. So that's 6 times it grew, or something happened where it's 6 times bigger now. So it's now 36, right? So that is a 600%, right? It's now 600% of the original. That is not our answer. Our answer is 500, because what we're looking for is the percent that it grew. What was this amount here? What's this amount of change? The 30-yard change, the fact that we increased by 30 yards. How much is that change? And from 100 to 600, we gained 500%. So that's what we're looking for. We're looking for how much did it grow, or how much did it shrink, okay? So 120 meals to 52 meals. Let's actually do this one not backwards, but let's do this one using that diagram, and then we'll show how it works with the just equation, because the equation is certainly simpler. So 0% of anything is 0, and this is now meals. And 120 was the full amount. It did shrink So I'm going to put the 100% at the end since it did shrink. So 120. And we do know that it's a decrease. So it's some percent decrease. And it was 120 and now it's 52. So 52's half would be 60, right? So halfway would be 60. So 52, pretty close to halfway. So 52 meals is here. Is a meal, not 52%. So you might say, what goes into both 52 and 120? 4 goes into both of those. So it's 4 goes into both. So let's put 4 here, 4 meals. And let's say, how many times does 4 go into 120? That's 30. There's probably a bigger number that went into both. 4 just came to my mind. And so then divide this by 30. And 100 divided by 30 is 3.33333333333333. So don't take that out of your calculator. That's not our final answer. So 3.3, percent, 3.33333%. And then multiply by 13 to get to 52. So multiply this by 13, and that will get us, so 43.333333333%. That is not our answer. That is not our answer. What are we looking for? We're looking for this decrease. It was at 100 and it went down to 43.33333. So what did it decrease here? It went down what percent? So what's 100 minus, right? 100 minus 43.333333333. All right, so it decreased 56.6 repeating percent. So that was the decrease. It decreased 56.6 repeating percent. Okay. How can we do this using the formula? Well, to get the percent of change, we just need to get how much did it change and compare that to the original. How much did it change and compare it to the original amount? Okay. So, well, it went from 120. So it went from 120 to 52. So that's the change. This is the change. So 120 minus 52 is 68. So it changed 68. It went down 68 meals. And we're comparing that to what it was. And it was 120. And then so to get that as a percent, we just divide. So divide 168 divided by 120 is 0.5666666666666666. Remember, now we want that as a percent because we're looking for the percent of change. So move the decimal place twice. And what do we get? We get the percent of change is 56.6 repeating percent. That is the percent of change. Okay, and then be careful. It is that much of a decrease. That matters. You got to put that word. So it's 56.6% decrease. Okay, so use the equation. Just change over the original, or good old friend, the double number line. All right, next. All right, so number 22. You estimate a jar contains 68 marbles. The actual number of marbles is 60. So find the percent error. Okay, so the percent error is found by taking the amount that you were off. What was the error? and you're comparing it to what the actual or expected amount was. In this case, it's comparing it to the actual amount. All right, so we guessed 60. No, we estimated at 68. So if we estimated at 68 and the actual number of marbles was 60, all right, so our estimate, so what was our error? So we said 68, it was actually 60, so we were off by 8. 8 was our error. And what was the actual number was 60. So to find the percent error, we take the error and compare it to what it actually was. Okay, so 8 out of 60. So how much were we off? What percent were we off? So 8 out of 60 as a percent, right? We could get it to 100 or just get it to a decimal and then turn the decimal into a percent. I'm going to go with that method. Take the decimal and then turn it into a percent. So 8 divided by 60 is 0.133333333. And then to turn that into a percentage, we move the decimal place twice. So it's going to be right there. So our percent error, we were off by 13.3%. That was our percent error. We were off by that much percent. Okay, so that's a percent error problem. So you take the amount now. Okay, next. All right, so table shows the number of skim boarders at the beach on Saturday and Sunday. What is the percent of change in boarders from Saturday to Sunday? So first of all, it is a percent increase or decrease. So Saturday it was 12, Sunday it was 9, so it went down, so it's a decrease. Okay, so what's this change from 12 to 9? The change is 3. So the percent of change, we get the change and we compare it to the original amount, in this case, 12. All right, so 3 out of 12 is 1/4, right? And 1/4 is 25 hundredths, and move the decimal place twice, we get 25%. So it decreased by 25% from Saturday to Sunday. We had a 25% decrease in the number of skim boarders from Saturday to Sunday. All right, visually, if you wanted to diagram this out, whoa, really dark lines there. So 0% would be 0 people skimboarding, 0 people. Saturday was the 100% mark. So Saturday there were 12. Sunday there were 9. All right. And remember, we're not looking for that number. We're actually looking for this here, the percent that it changed. We know that it went down some percent, but we're looking for that amount there, right? This 3 people, the 3 people change is what percent? What is this amount of percent that we lost? All right. And then, so you'd probably go to 3 here, right? We'd probably say, hey, what's 3 people? Right? What's 3 people? So divide by 4, divide this by 4, and we get 25. We get 25%. Oh, and hey, look, 3 people is 25%. So if we go down 3 people, we go down 25%. Okay? If you didn't notice that, we would times by 3 and times by 3. And get that this amount is 75%. 75%. And then sure enough, from 100% to 75%, what amount of decrease is that? What percent decrease is that? And that's a 25% decrease. All right. So that's how to do it with the diagram. Sorry, it's a little sloppy. Okay. So 25% increase, that is percents of increases and decreases and percent errors. Thanks for joining me. Catch you in the next one.